Hey everyone, in this lesson I'd like to make a review of how can you replace emitting low-res soft body vellum geometry with a high-res one. Um, in a previous lesson we did a setup on how to replace the rigid body geometry. In this one, it's almost the same, has a little changes made to the setup. So let's see. So this time we have our geometry high res and low res, and I'm applying an attribute to the low res and calling it low res geometry. Okay, and I merge them together and apply an overall name attribute. So in this case, I should have a low res and a naming attribute. Okay. So the same is done for the rest of geometries. Then we have our distributor, point distributor. So it's the same as in previous lesson. So we have a sphere, we have some transformation applied to it, sword with a shift method and $f expression, and this one uh, we might actually turn this off, but in case I simply applied some additional information. So then noise, again we have noise, scale, and the orient attribute. And yeah, the same we did here for the points. So we're using the metadata to um, copy a single geometry onto the points, and so we're using detail expression, our metadata, attribute iteration, and modules by 4. This will give us the overall geometry, which has the low res and high res one. And again, I'm promoting my attributes to primitives, assemble back to the geometry, and this is what we have. Again, changing geometry. But this time we have them both, the high res and the low res, as a collection. Okay, again, the delete attribute of non-selected. So each frame we have different geometry. Okay, and since we have them positions very close to each other and intersecting, I would like to first of all apply the name and plus the frame of the geometry that being produced. Okay, so if I spreadsheet that, since we're doing on primitives, each time we have a geometry and different naming. Next, as I said, since we have each frame produce geometry which is positioned too close to each other and intersecting, we are using this blast with expression, so we would like to keep only the geometry that emitted each 5 frames. Okay, so by 3, we don't have geometry. If I go 5, we should have geometry. So this way we create a gap for the simulation not to kind of distract each other. So next we have unpack geometry and exclude the high-res one, and we send it to our Vellum simulation. Okay, and here, since we know that the simulation will take only first frame, we would like to kind of import our producing geometry into our Vellum. So we use the Vellum source, and um, we select each frame um, of our geometry and the constraints. Okay, this way we'll produce Vellum geometry on each uh, fifth frame. Okay, so I cached it, so you can see this is our solid body, low res. Okay, and next, the same as here, we're unpack, and this time we're excluding the low res geometry. And since we are producing every fifth frame, so here we have HiRes tube. Here I'm also applying some attributes that I will use later. And here in the pop solver, in the solver node, I'm simply merging the previous frame and the current frame. So this way, I'm collecting all the geometries that appear through the timeline. Okay, let's see. Okay, so this is the cached version, and here you see I'm collecting all the geometries, and if I simply template that, and we will start frame 0, frame 5. So you see the high res and the low res, they are placed in the same position. So now I'd like to use the pointer form, and in for each loop, I would like to low res drive the high res one, and here we're using the naming to sort the geometry, and here I'm using this for each begin for naming. So since they have the same naming, as we merged them and gave them the same name, it should work. And if I since in for each node we can't see an update, if I go in 5, say, so as you see, it's placed exactly high res and low res spheres. Then the standard method for pointer form and the res geometry and simulated geometry, and here we're simply uh, freezing our geometry. Uh, and yeah, we're using this attribute to um, to have, I think, exactly the framing that we need. Right, and yes, yes. So, and this way, by using the pointer form, we can actually catch the high-res geometry by the low-res one. Okay, and so there is a small gap. It was actually my mistake, since I think I've used. I should have lowered down the thickness of the vellum geometry. So I used the peak, which actually solves the problem. Okay, so this way, how can you deform your high-res geometry with the low-res one? And plus to it, I used the same method, but in that case, I'm deforming the points from volume. So I'd like to add some grains inside of the geometry. So this is, so we have some points are outside of geometry, and I think we're solving that by using, yes, by using the volume selection of the actual geometry. And the rest are tweaks. So I'm copying the colors uh, of the main geometry, and then I'm applying some geometry to the points. But you can actually um, render those points without applying geometry. But um, and some attribute conversion, so you can use it during the render time. So yes, this is all I'd like to share in this lesson, and I hope the lesson was useful. Uh, if you find it useful, please like and subscribe, and I'll see you in future lessons. Thank you very much, and goodbye.